The Australian Financial Review.
In the thick bush of Victoria's Otway region, Sequoia Lewin is looking for a needle in a haystack.
I'm looking around at the moment to see what species are around because we'll need to record these as we do our collection. Black cockatoo.
So right now we're walking through the bush in the eastern Otways in Victoria, probably about 70 minutes out of Melbourne. I've got a big sort of pine tree on my left and some sort of native stuff on our right as we walk through this clearing.
There's a massive diversity here. If you think about all the tree species we're walking past, we're seeing acacia, eucalyptus, tea tree, melaleuca, pine trees as well.
If there's one industry that's just about certain to boom as the world fights climate change, it's tree planting. Governments around the world have promised to plant trillions of trees and reforest millions of hectares of degraded land. Trees are the cheapest and the most proven carbon storage device known to man. And in a world that can't seem to agree on whether carbon capture and storage is a good or bad thing, trees are a carbon sink that just about everyone's happy to embrace.
This is part of a new global forest finance pledge of over, wait for it, of over $12 billion, amounting to the biggest collective commitment of public funds for forest and climate action in history.
But what if we could find a way to make trees grow stronger, faster and healthier, more capable of sucking down carbon and providing habitat to animals? The company Sequoia works for reckon they've done just that. They're called Rhizocor, and one of Australia's most famous billionaires is so convinced he's bought a stake in the company. But the whole thing depends on Sequoia finding a tiny, special ingredient on the forest floor. So we come through off the beaten track into a nice little clearing in some thick scrub, and bingo, Sequoia is down low at ground level. She's inspecting something.
And it's a perfect specimen.
So put on your hiking boots and pack your trail mix, because today on Tech Zero, we're showing you how to turbocharge trees. Promising action on climate change is the easy part. Delivery is so much harder, and right now, the world is finding it hard to live up to its promises to tackle emissions. But not everyone's given up. I'm Peter Kerr, and welcome to the Tech Zero podcast, where we bring you the big green ideas that could get us to net zero and the people risking everything to make them work. If I challenged you to name the most biodiverse place on Earth, what would you say? Galapagos? Borneo? You're probably thinking about the Amazon, I imagine. Well, guess what? It's actually on the southern outskirts of London. Yep, about 55 k's out of that massive city, there's this underground bomb-proof shelter. They call it the Millennium Seed Bank, and it's home to more than 2 billion seeds. It's a real-life Noah's Ark for the plants and crops that humans depend on.
While I was working there, I think had about 15% of the world's seeds stored within its freezers. There's crates of seeds with country names from pretty much every country in the world. It's this kind of resource in case those species go extinct and we want to work with them.
That voice you just heard, that's Dr. Toby Parks. He's the founder and CEO of Rhizocor, so that makes him Sequoia's boss. And he was working at the Millennium Seed Bank when he had his light bulb moment.
It was really when I was working with a group of orchid species that I properly got immersed with this world of symbiotic fungi.
You probably remember the word symbiosis from biology class at high school, right? It basically refers to two organisms that live in harmony, providing each other with something special that they can't make themselves. The best example in the animal kingdom? It's probably those little pilot fish that swim around with the sharks, gobbling up the little crumbs and providing a free dental service to their big friend. Many plants get by with a little bit of help from their friends too. And for many plants, their version of the little pilot fish are mycorrhizal fungi. Now, I know it's easy to tune out when you get a big scientific word like that thrown at you, but this one's worth investing in because mycorrhizal fungi are the star of today's show. These fungi live underground and create a web of fibres that are brilliant at soaking up water and nutrients. But being underground, they don't see the sun, which means they can't photosynthesize. So they need to find a friend who can.
And they form a association with the plant root where the fungi pump nitrogen and phosphorus into the plant. They naturally fertilize the plant. And in return, the plant provides those fungi with sugars.
If our listeners have ever gone on a truffle hunt, is that an example of this in the real world?
Yeah, truffles are a group of fungi that are part of the mycorrhizal fungal group. And so they do this with trees typically. They form these associations under the soil with roots. And what a truffle is doing in the environment is pumping nutrients into those trees, and it gets its nutrition from the tree. And so truffle species are mycorrhizal fungi.
As you listen to this next bit, I want you to keep in mind that fungi are not animals. They do not have a brain. They're just a bunch of cells programmed to multiply as fast as possible. But listening to Toby, you'd be forgiven for thinking they were emotionally intelligent little critters.
When a seedling or a seed falls from a tree and germinates to form a seedling in the soil, that seedling will connect into the mycorrhizal network. But before the connection happens, the plant needs to first signal to the fungi to basically say, hey, I'm alive. I'm not in a good nutrient soil, and therefore I need nutrition. And so it will signal to the fungi being like, I'm ready to form a symbiosis, which then basically the fungi recognize those signaling compounds and then basically form this association with the root of the plant. And there is a bit of competition that also goes on in the soil with different mycorrhizas. If you have many mycorrhizas in the soil, then there'll be a competition for the root tip of the plant with other mycorrhizas. The fungi will basically give almost like a present. It's a package, a parcel of nutrients that it's going to deliver to the plant in its initial kind of setup phase of this association. And then the plant will basically pick whoever's giving it the best present to form the association. And that's what happens in a mature woodland when you have healthy populations of these organisms.
It's almost romantic, isn't it? Hey, speaking of romance, have you ever watched that TV show, The Farmer Wants a Wife?
Its eyes were the most beautiful thing I've ever seen.
It's about dudes who live in remote country towns where there aren't many prospective life partners around to choose from.
How can a guy like you be single, though?
There's the whole reason why this show's made. Probably not even 8 ladies in my hometown.
Well, it's a bit like that for trees and fungi too. When it comes time to planting trees on old farmland or forestry land, the soils are often devoid of the fungi that helps trees grow. That leads to high mortality rates among the saplings, and it's something we're going to have to fix if we're going to convert millions of hectares of degraded land into forests between now and 2050.
Most of the problems come when we try and plant trees or put plants in areas where there aren't healthy populations of mycorrhizas, and that's really kind of where we work.
Farmers and forestry companies are among the biggest players in the tree planting game. So Toby reached out to those industries to see how they were using mycorrhizal fungi to bolster tree growth in their plantations. And he was shocked by the answer.
I was asking the forestry industry where they were using mycorrhizal fungi, thinking that we'd be trying to find ways of improving them. The answer came back to me that they weren't using mycorrhizal fungi really in their process. And half of the time they said, what are they? And so I very quickly realized that the problem wasn't how do we improve this in the system? It's more how do we get symbiotic organisms incorporated into planting systems more generally. And that was really the kind of moment that I realized that there was something that we could do here, and what sent me down the path that led to the formation of Rhizocore.
Toby's big green idea was to provide the forestry industry and anyone else planting trees with a mycorrhizal fungi that they can effectively buy off the shelf and use at their convenience. His company Rhizocore now make that product. They're little pellets, and they look a bit like sugar cubes. The guest of honour inside the cubes are the mycorrhizal fungi, but they also contain enough nutrients to keep those fungi alive for 6 to 12 months.
One of these pellets gets put beside a tree when it gets planted in the soil, so that basically the source of the fungal the symbiotic populations are present in the soil next to the tree when it gets planted. The value that our customers derive from our products is about improving the survival rate of those trees and decreasing the mortality rate post-planting. And also it's about increasing the growth rate of those trees, particularly in the first 5 to 10 years.
Are you able to quantify the benefits that your product gives compared to, a tree next door that doesn't get one of your pellets? Like, how much faster does it grow? How much bigger? How much lower is the mortality rate?
Like, typically a forestry industry in Europe and the UK will have somewhere between a 15 to 25% mortality rate of the trees in the first 10 years. We've been able to show that we can drop that to around 3%. We're expecting to see growth rate improvements in the first 10 years of the trees, on average about 20%, but it's very, very specific to conditions. And so basically the poorer the soils on the site, the greater the impact that we see.
There could be huge demand for this kind of thing in future if nations live up to the big promises they're making on reforestation. You see, just about every credible pathway for getting the world to net zero relies on a dramatic boom in tree planting to suck carbon out of the atmosphere. I'll give you a few examples. American President Joe Biden has ordered the US Forest Service to plant 1.2 billion new trees by 2031.
Conserving our forest and other critical ecosystems is an indispensable piece of keeping our climate goals within reach.
Across the Atlantic, the European Union has vowed to plant 3 billion additional trees by 2030. And when China heard about that goal, they said hold my beer and promised to plant or conserve 70 billion trees by 2030. Yes, 70. 70. Now, we've seen enough climate pledges get watered down in recent years to take all of these promises with a grain of salt. The early signs suggest those superpower economies are already behind the pace required to achieve their tree planting goals. But the trajectory is clear. At last year's United Nations Climate Summit in Dubai, the text contained a pledge on reforestation for the first time. I'm going to get my producer, Lap Fan, to read you the relevant quote, where the signatories said that they would make
enhance efforts towards halting and reversing deforestation and forest degradation by 2030.
Cheers, Lap. So while the rich countries promise to plant more trees, the developing nations that haven't yet cut down their forests want to be paid better to preserve them. You might have seen that video earlier this year in 2024 where the president of Guyana got fired up at a BBC reporter over this exact issue.
According to many experts, more than 2 billion tonnes of carbon emissions will come from your seabed and be released into the atmosphere.
Let me stop you right there. Do you know that Guyana has a forest forever that is the size of England and Scotland combined? A forest that we have kept alive.
Does that give you the right? Does that give you the right to release all of this carbon?
Does that give you the right to lecture us on climate change? I am going to lecture you on climate change because we have kept this forest alive that stores 19.5 gigatons of carbon that you enjoy, that the world enjoy, that you don't pay us for, that you don't see a value in. Guess what? Even with our greatest exploration of the oil and gas resource we have now, Guyana will still be net zero.
So while governments work on their green thumbs, big corporations are also planting trees at a rapid pace. And Toby reckons Risercor's biggest revenue stream in future will probably come from companies planting trees to try and offset their carbon footprint.
And so these tend to be large corporates that are buying areas of land to plant trees for generating carbon units to offset their own business emissions. I expect this type of organization to become potentially our largest customer in the future. We're seeing large corporations move to this type of model already, and we've already got active conversations with some of the biggest companies on the planet about this. And so we can see that they're projecting that the price of carbon could get to a point where it just makes more economic sense for them to do it in-house rather than be buying offsets from a global market.
Toby and Risercor are based in Scotland, and most of their work to date has been with the British forestry companies. But in mid-2023, they went looking for investors, and a big chunk of the money that came in was from Australian investors. Two in particular stood out. The first was Dan Fitzgerald. He's a former Macquarie and UBS banker who now runs his own climate tech fund called Regen Ventures. The other was Grok Ventures. That's the private investment house of the Atlassian founder Mike Cannon-Brookes. And Grok said they see huge potential for this in Australia, where soil rejuvenation needs to happen urgently.
So 2 very strong Australian links that we have there. And then obviously that's led to us setting up the Australian team.
But if Rhizocore is going to seize this opportunity, they're going to need a lot of that active ingredient that sits in the middle of those pellets. And for that, they need people like Sequoia Lewin to go foraging in the forest, collecting the live specimens of mycorrhizal fungi that they can take back to the lab for cultivation. And after this short break, you'll hear what happened when Sequoia took us deep into tiger snake country, looking for fungi. Oh, you found one? Oh, excitement is building. We think we have found one. Did you ever think that you could get a job where you're paid to just like go on a bushwalk?
I would do anything to work in the bush. I absolutely love it out here.
I believe we're going foraging for fungi, is that right?
Absolutely. So we're looking for mushrooms that associate with trees. We're looking today quite specifically for those species that form these symbiotic relationships.
Is a mushroom like the fruit people think about an apple on an apple tree being the fruit of the tree? Is that really what a mushroom is? It's the fruit of a fungi?
Essentially, yes. It's the reproductive structure.
Sequoia, we're looking for mushrooms, but why? Like, this presumably isn't just trying to find our dinner, is it?
No. So on another occasion, I might be out here foraging for wild edible mushrooms. But this time with Rhizocore, we're actually looking for fungi that we can collect and take back to our lab in Sydney, isolate them, grow them out, and then conserve them. And so in our lab, we tear open the mushroom and take a piece of tissue, and we place this onto an agar plate that has specific nutrient conditions designed to help that fungus grow as best as it can. And then once it's grown to a certain stage, we do a DNA extraction, so we see exactly what species that is. Eventually, if we decide it's a strain that's either going to be used to form a pellet, which then can then be planted with trees, or it's going to be put into cold storage, so long-term storage, and this is how we preserve our species. So at minus 80 degrees, we leave them in cold storage.
And this is where the Rhizocore story gets really ambitious. Remember how Toby got his start at the Millennium Seed Bank in England? That's the place where taxpayers' funds are used to build a giant Noah's Ark, which stores seeds and could help us if plant species start to go extinct. Well, fungi are crucial for ecosystems too. Many plant species are entirely reliant on them and would be effectively extinct without a fungi friend to bring them to life. Yet taxpayers haven't spent anything building a Noah's Ark for fungi.
So this is a good example of why public funding for this type of work is important. And so plants, for a large degree, are quite well publicly funded. And for animals, we have zoos, which again, there are public funds available for that, but it's also relatively privately funded by people going and wanting to see animals. For fungi, we really don't have any good global collections. And fungi are pretty vitally important because they are less visible and relatively understudied compared to the other two groups. We don't really have the same types of protection and repositories for that biodiversity that exists out there. And so we kind of recognize that that's a problem. We are a repository and a global resource for the protection of fungi as one of our central missions.
I would imagine that big Noah's Ark of fungi that you're creating around the world one day is going to have an enormous value.
We see that the fungal collection and repository that we're building, with the way that we're also building the expertise to be able to use that to help solve problems. It's one of the things I criticize about the Millennium Seed Bank partnerships and stuff like that, is it's a fantastic resource for the planet. Probably one of the most important live resources that we have anywhere, but it's vastly undertapped in terms of what it could do for us and the knowledge that we can generate and gain from it. What I'm building with Rhizocore is not only the repository, but the expertise from the scientific community and the team that we've built around this to be able to harness and use that knowledge to help solved global problems.
And is climate change threatening the world's fungi population?
Absolutely. Well, climate change and man-made disturbance, in the same way that we lose ecosystems because of human populations clearing large amounts of land for agriculture, we lose fungal species at the same rate that we lose plant species and animal species. The only difference is we don't really document it to the same level, but fungal biodiversity is being lost at the same rate, maybe even slightly faster.
Back at the Otways, things were looking grim. We'd been walking around for over half an hour without any sign of a mushroom. And to someone like me who doesn't know anything about fungi, it feels like we're just walking through the bush. But I can notice your eyes are closely studying the topography of the ground. Is there a particular type of ground that you're looking for where you think we're most likely to find these mushrooms?
Yeah, I'm kind of aiming for certain trees, so particularly the eucalyptus species, and then looking around the base, the edge where their roots might be occurring, because fungi will often pop up in this zone. I'm also looking for areas that are a bit damper. You might be able to hear that it's quite dry underfoot at the moment, but fungi need moisture to be able to create their fruiting bodies. So that's kind of what my eyes are searching for at the moment.
Well, your eyes stay on the ground for mushrooms. I'm going to keep mine down for tiger snakes, just in case. Is that
That's a good idea.
Okay? Yeah. And do you like eating mushrooms, or would that be like taking your work home with you?
I love eating mushrooms. My background is actually as a chef, so some of my earliest interests in mushrooms came from cooking them in the kitchen.
Oh, wow.
Yeah.
And was that as a way I was about to ask Sequoia for her best mushroom recipe when suddenly our patience paid off. So we've come through off the beaten track into a nice little clearing in some thick scrub, and bingo, Sequoia is down low at ground level. She's inspecting something that looks like a sort of classic button mushroom. It's sort of cream coloured, a little bit sort of brown in patches. Sequoia, have we found one?
We have found a fungus. I wouldn't call it a mushroom because mushroom typically refers to this umbrella-shaped structure with something that has gills. This is actually an earth ball in the genus Scleroderma. So that's referring to its rough skin on the outside. So these form as a ball which protect it a bit more from the dry conditions. So I was hoping to see the species today. It is ectomycorrhizal, so it's associating with eucalyptus trees and some other species.
So do you think you'll collect this one today, or is this one?
Definitely will.
Yeah, great.
This is a fantastic species to collect, and it's a perfect specimen. If we find this mushroom here, then we know the mycelium is inhabiting the soil, and it can produce mushrooms elsewhere as well.
So the scoreboard reads, mushrooms 1, tiger snakes 0. That's the kind of equation we want today?
Yeah, that's ideal.
But the scoreboard didn't stay at 1-0 for long. Within a couple of minutes, we'd found a second and a third Scleroderma barely 5 metres away. Sequoia started gently easing these little fungi out of the ground and placing them in a big collection box.
What I'm going to do is just wipe away some of the dirt and just make sure to take all of that out of the ground.
So Sequoia's now pulling it up very gently in a way. Were you deliberately sort of being gentle to make sure all the sort of roots on the bottom stayed intact?
So I didn't want to break the mushroom, because if you break the mushroom off too close to the body itself, it can create wounds where contamination can get in.
Sequoia's using her fingers to pull off as much of the sort of sand and dirt off the roots, and as she does that, the root structure is becoming clearer. We can now see it. Now it looks like a little octopus. You've got a little circular sort of head atop a branching out little bunch of roots at the bottom.
So these actually aren't roots. This is the mycelium that I was talking about earlier. So this is the organism itself. So the mushroom is just the reproductive structure, but here you can see the full organism.
And so we found 3 of these little earth balls within about a 5 metre patch of the bush here. So would they have all been connected by underground sort of fibres, effectively.
Yeah, so you see 3 mushrooms. How many fungi are there? Just 1. It's entirely likely that this is all one organism. So I'm just going to place this in the box now. I've also recorded some data about the GPS location, the nearby trees. So we've got a couple of acacia species and some tea tree. So it could be associating with any of those plant species. I'm saying it's probably the acacia just due to the size of this tree here.
And it has been helping this acacia grow strong. This acacia is probably 20 metres tall, and at its base, that trunk is pretty thick. Like if I hugged the base of this tree, I might just get my arms around it. So has that tiny little earth ball and the rest of its connected fungi been helping this tree grow strong?
Absolutely. So Scleroderma in particular has this really long, ropey mycelium that can spread and travel large distances as it searches for nutrients to access.
It made me wonder how tall that acacia tree would be if the mycorrhizal fungi hadn't been growing down around the base. Would it be 18 metres rather than 20? Would it even be there at all? With any luck, pellets made from the fungi that Sequoia collected there will be planted with a new tree sometime very soon. Rhizocore's first Australian project is going to happen very soon at a Queensland chicken farm. Their pellets are going to be planted with little saplings on paddocks that used to be part of the farm and are now being reforested. Here in Australia, we're used to thinking that we're laggards on climate action. But as Toby expands his business down under with a bunch of new Australian shareholders, he reckons it's not all bad.
You guys are ahead of the game, I would say, in terms of your carbon credit markets and how they work with tree planting in particular. That makes a good market for us to be entering.
So Sequoia, our foraging mission in the Otways today is coming to an end. How many did we find?
So we collected 3 specimens. So given the dry conditions, I'd consider that successful, and we'll definitely be looking to come back to the Otway region after we've had some more rain.
Will any of them be going into dinner, or are they all going back to the lab?
No, they're all going back to the lab.
All right, well, Lap and I might go to the pub for dinner then instead. Thanks for having us
Sounds
today.
like a good idea. Thank you.
Cheers. Thanks for listening to Tech Zero. We'll be back in 2 weeks' time with another episode. This podcast was hosted and written by me, Peter Kerr. It was produced by Lap Fan and edited by Martin Peralta. Our theme music is by Alex Gow. Big thanks to Cormac Lally, and the executive producer is Fiona Buffini. If you like the show and want to hear more, follow us on Spotify, Apple, or wherever you get your podcasts. And please consider rating us or reviewing us, because it helps other people find us. At the Financial Review, we investigate the big stories about markets, business, and power. To subscribe to the Financial Review, go to afr.com/subscribe. You can also get in touch with us at techzero@afr.com. Tech Zero is part of the Financial Review's Carbon Challenge franchise.
The Australian Financial Review.